Assalamualaikum and good day. My name is Ibrahim Murad and my supervisor is Sultan Muhammad Firdaus bin Aziz. Today I will talk about my research on rice porosity, biodiversity, effect on Cytophilus oryzae, oviposition distribution on selected Malaysian rice. This is our agenda. So I will talk about introduction, literary review, result and discussion, conclusion and recommendation, and reference. In the developing of the world, the career crop is most valuable is the rice because half of the world of the population consume and making the rice as primary food source. In Malaysia, a dish based on rice is well used in all states of Malaysia. The average food consumption sequence by an adult Malaysian people is 2.5 plate of rice per day. And according to the Kuma 2011, the largest producer and consumer is Asia. The rice weevil or scientific name Cytophilus oryzae are tiny pantry pests that infest and also feed or store food products. A current grain food at temperature 27.5 degrees Celsius and humidity level of 70% S. oryzae can be cultivated. So, the female S. oryzae cut a hole in a grain kernel with her sharp mandibles, which inside the hole is will implant a single egg and seal it with a chemical from her ovipositor. According to the Coahuila 2018, mature female rice will release 4 eggs each day on average and can survive over 4 to 5 months. In around 3 days, the egg will hatch. Problem statement. As we will have a different oviposition distribution which making the research hard to detect. It has a limited study for the oviposition distribution of S. oryzae. Then, when collecting the sample, there will be a random age of the rice weevil. If the insect sample collect an older rice weevil, it's being probably died before the research can use to get the oviposition distribution. This will lead to the lack of the data that needed. Then we continue with the significance of the study. The increasing of the population of S. oryzae can affect the economy that produced the rice, as we know that in Asia was the largest producer and consumer of rice worldwide, which making the rice as their primary food, which with the study of the oviposition distribution, it will help to control the population of S. oryzae, which can be controlled by temperature, humidity, and the location store rice. This data can provide the researchers to continue this study in the future. In this study contains of 4 objectives, which is to determine the rice porosity and bulk density of Baboy and Basmati rice, to determine the adult and oviposition distribution of S. oryzae on Baboy and Basmati rice, to analyze effect of the rice depth on vertical distribution of adult and oviposition of S. oryzae, to determine the association of the rice porosity bulk density toward the adult and oviposition distribution of S. oryzae. Cytophilus oryzae is tiny pest from the Corchelinidae family under the Cytophilus genus. It looks nearly identical to the granary weevil. It's reddish-brown to black in appearance with 4 bright yellow or reddish marks on the elytras corner, which are the hard protective furrowing. This species usually attack the grain product, but it's mainly a grain pest of entire in stockpiling or pantry. Behavior of S. oryzae are internal feeder, which is insect larvae that consume the whole kernel. This internal feeder making S. oryzae unable to detect until the adult exit from the kernel. Rice weevil is more attracted to the blue wavelength, which be recorded at 84.3%, followed with the other wavelength, which is green, red, UV light, and infrared. It will drop to the ground and pretend to be dead. These are their survival behavior to protect from the enemy. The first result is the measurement of length, width, and thickness for the parboiled and basmati rice. As we can see from the graph, the basmati rice has a higher length than the parboiled, but basmati rice has a low measurement of the width and thickness than the parboiled. Most of the rice is long grain rice, but it has different in processing and nutrient. So this is the second result, which is reciprocity of Baboy and Basmati rice. As we can see from the table, the reciprocity for the Baboy has the higher compared to the Basmati. But when we look in the bulk density, the Baboy has a lower bulk density compared to the Basmati. This shows that porosity increase as the bulk density decrease, which is the inverse relationship between these two. The amount of the air gap in the overall volume of the bulk rice grain, which is made up of the mixture of rice grain and air, will have an impact on the bulk rice. Baba had a higher rice porosity because it has more pore or space when it being put into the container compared to the basmati, which is a lower pore. Oviposition distribution is showing that variance mean ratio for adult and emergence for the boost of the rice, which is parboiled and basmati, showing that the value more than 1, which it can be indicated as the presence of the clump in the distribution. The factor that cause clump at the top of layer of container because the S or Z can easily transfer into another container as we know that as RIZ characteristic, they have a wing that can be used to fly to another open rice container. The other factor is that SRZ can finding a mate when there are many number of the SRZ at that area. Results show that the rice depth on vertical distribution, which is for adult and emergence. For the adult, we can see that most of the SRZs stay at the level 1 compared to the level 6. The level 1 is the top layer of the container and the level 6 is the bottom layer of the container. Same goes to the emergence, which they tend to stay at the level 1 compared to stay at the level 6. This shows that the deepest the rice depth, the number of adult and the new emergence is decreasing. This happens because the bottom layer rice depth, the oxygen is limited compared to the top layer, which has higher level of the oxygen. The low level oxygen, also known as hypoxia, at 1% of oxygen level, it can cause the S organism not survive beyond 14 days. It shows that the higher level of oxygen, the higher number of S organisms can survive. Test of independence using the chi-square, which is showing that p-value for the adult and emergence for the bulk density and rice porosity is higher than the alpha value, which is 0.05. In this research, if the p-value is greater than 0.05, the null hypothesis is failed to be rejected. However, if the p-value is lower than 0.05, the null hypothesis need to be rejected. So, we can see from the table, the p-value is higher than 0.05, so that null hypothesis is failed to be rejected. The null hypothesis in this test is no association, which is the bulk density and the reciprocity are no association on the adult and oviposition distribution of S or Z on the parboiled and basmati rice. As conclusion for this study, showing that rice porosity for the parboiled are higher compared to the basmati rice, but basmati has higher bulk density compared to the parboiled. Using the VMR or variance mean ratio, showing that the presence of clump in the distribution of S or Z, then the number of adult and the oviposition distribution at the top layer has higher number compared to the lower layer. Finally, the bulk density and the rice porosity are not affecting the S or Z oviposition distribution. Recommendation of this study. It's recommended to know properly the suitable place for the SRZ because if the container being placed at the place that have low amount of moisture can affect the process of oviposition. The temperature and the humidity need to be recorded in data because it also can be used to explain the other results such as the different depth of the rice which might be affected by the humidity and the temperature. Finally, when in the middle of the experiment, avoid or minimize the changing or movement of the container that being filled with the SRAZ from another place to another place. This is because the changing place or any movement can interrupt the oviposition distribution. That's all for me. Thank you for watching this video.